Lesson 19.1, Task 2. Identify transformations of the graph of f of x equals x squared. Previously, you learned how to stretch and compress, translate, and reflect the graph of a linear function. You can also perform similar transformations of the graph of the parent quadratic function f of x equals x squared. A stretch, compression, or reflection. You can vertically stretch or compress the graph of the parent function by multiplying the range values by a non-zero number a. You can reflect the graph of the parent function across the x-axis by multiplying the range values by -1. Alright, so it gives you several functions here. F of x is your parent function. You can see that is the line here, or the parabola in black. And then you've got p of x is 2 times x squared. P of x is the green line here. So 2 times x squared. And then you've got r of x equals -2 x squared. So r of x is the reflection of p of x. So it's upside down because it is negative, but it's still 2x squared. All right, g of x equals -x squared. So g of x is the blue line here, and that's the reflection of f of x. And then you've got q of x. Q of x equals 1/2 x squared, so that's the red line here. And then s of x equals, that should say -1/2 x squared, because you can see that's a reflection. So that one should be -1/2 x squared. All right, identify which graph represents each transformation of the graph of f by using its letter. All right, so a stretch only. All right, a stretch only, so it's going to get closer to the y-axis, so that's going to be our p of x function. So it says identify which graph represents each transformation of the graph of f by using its letter. All right, so we're going to put letter P in for our stretch. All right, P of x equals 2x squared, and you can see that right here on the graph. All right, a compression only. So a compression only goes the other direction. It's compressed towards the x-axis, so that's going to be our q function. That's the red one. A reflection only, so a reflection only means of the parent function, which means of f, so that would be our g function. A stretch and a reflection. All right, a stretch and a reflection. That one would be r. And a compression and a reflection. All right, that one would be S. And again, it says this one should have a negative sign there. So S of x equals -1/2 x squared. That's what makes the reflection. So that one is S. And that's just talking about what happens if you translate the parent function. All right, so a horizontal translation, you can translate the graph of a parent function horizontally by adding a non-zero number h to the domain values of the function. So if we have f of x equals x squared, m of x equals x plus 2 squared, and n of x equals x minus 2 squared. All right, so you can see m moves you 2 units to the left, and n moves you 2 units to the right. So it says choose the function to complete the statements. Blank represents a translation of the graph f to the right. All right, so this is left, this is right. So to the right would be our function of n. Blank represents a translation of the graph to the left. You can see the red moves to the left and it becomes m, our function m. And the way I remember the horizontal translations, I remember that it's always going to move opposite the way you think. Because remember, your negative x's go to the left. and your positive x's go to the right. But when this says x plus 2, you actually move to the left. And when this says x minus 2, you move to the right. So the way I keep track of this is if it's a horizontal translation, it's going to be opposite. You're going to move opposite the direction you think it's going to move. So even though you're going from 0 to negative 2, this is x plus 2 squared. Okay? All right, a vertical translation is a little easier because it goes exactly the way you expect it to move. So you can translate the graph of a parent function vertically by adding a non-zero number k to the range values of the function. So f of x equals x squared, v of x equals x squared plus 2, so you can see it's just moved up 2 units, and then w is x squared minus 2, which just shifts the whole graph down 2 units. So it says choose the functions to complete this statement. Blank represents the translation of the graph up. Up is our v graph. And blank represents going down, and that would be our w. All right, that's all for task 2. If you have any questions, let me know. Lesson 19.1, task 3. Graph quadratic functions in vertex form. Previously, you studied the standard form of a quadratic function. Remember, standard form was f of x equals ax squared plus bx plus c. Now you will study the vertex form of a quadratic function, which is f of x equals a times x minus h squared plus k, where a, h, and k are constants. You can graph quadratic functions written in vertex form by using the constants a, h, and k to determine how the graph is a transformation of the graph of the parent function f of x equals x squared. Transformations of the graph of the parent function f of x equals x squared. All right, so here's a lot of information about transformations. This is all really good information to have in your notes. All right, so it's probably a good idea to pause the video and read through some of these points because these are all important points that you need to know. All right, when you've had time to read through the video or read through all of the notes there, then continue on. So you may want to use a graphing calculator to complete task 3. It says graph both f of x equals x squared and g of x equals negative 3x squared. All right, so if you want to graph these on your calculator, all right, we're going to go to y equals, clear anything that's in there, but the first one we're just going to do is x squared. And then the second graph is negative 3x squared. I hit the wrong button there. Make sure x squared. Well, shoot. Let's try that one more time. Okay, x squared and negative 3x squared. So then we're going to hit graph. And it's going to graph just like here, but in your calculator. So those are easy to graph. If you have a graphing calculator, please practice doing so because that can be helpful to look at the graph. All right, so it says which statements about the values of a in function g and its effect on the graph of f are true. All right, so x squared and negative 3x squared. All right, so this one says a is 3. This one says a is negative 3. You can see here that a is negative 3. All right, it causes a vertical stretch. All right, that is true. It causes a reflection across the x or the y. It reflects across the x-axis. That is true as well. All right, how does the graph of p of x equals negative 3 times x minus 2 squared compare to the graph of g of x equals negative 3x squared and the graph of f of x, which is x squared? Select all that apply. All right, so you can see from this function here to this function, all they did was add the -2. Remember, that shifts the graph 2 units to the right. All right, so let's see what applies here. So it says it is a translation 2 units to the right of the graph of G. Okay, so that is true. So from G to here, from G to P, we shift it 2. All right, it is a reflection, stretch, and a translation 2 units to the right of the graph of F. Okay, that one is also true. So it already did these other 2 things. We already had the stretch and the reflection from F to G. Remember up here, we had the stretch and the reflection. So that came from F to G, and then from G to P, we added one more thing. So these down here do not apply, just the one that puts the 2 functions together. How does the graph of q of x equal -3 times x minus 2 squared plus 5 compare to the graph of p of x, which equals -3 x minus 2 squared? So you can see to go from p to q, now we're going to add 5, which is going to move it up 5 units. Remember, this is a vertical movement. This is a horizontal movement opposite the sign. All right, so it is a translation 5 units up from the graph of P. So from this graph to this graph, it simply moves it up 5 units. How does the graph of q of x equals -3 times x minus 2 squared plus 5 compare to the graph of f of x equals x squared? All right, it's a reflection, compression, translation left, and a translation up. Reflection, stretch, left and up. It's a reflection, a compression, a translation right, and a translation up. It's a reflection and a stretch. We know the first step was a reflection and a stretch. A translation to the right. It goes right because it goes opposite the way you, let me see here. Left. Yes, it goes opposite the way you expect it to. Since this is -2, it's going to translate to the right, and this one goes up. So the fourth answer talks about each movement that happens because of the different parts of the function there, the different numbers that are added. All right, so it says refer to the graph of f and q, compare ranges and in behavior, compare whether the functions are increasing and decreasing, whether the functions have a minimum or maximum value, and what the value is. Compare the average rate of change for f of x over the domain 0 to 1 to the average rate of change of q of x for the domain from 2 to 3. Describe how the values of a, h, and k impact the key characteristics of Q. All right, so there is a lot of information crammed in here. So I want you to take a minute and read through all of this because this is a very good description of what it does. So it talks about the range, the end behavior. All of these are key features that you must know and know how different functions compare. So please take a moment, pause the video, read through this, and then that is the end of task 3. If you have any questions, let me know.